Position vector of a particle is given by r is equal to a cos omega t I cap plus a sin omega t j cap. The velocity of the particle is. So position vector is given by a cos omega t I cap plus omega t j cap, a sin omega t j cap. We have to comment on the velocity. This is position vector is given. So since we know that velocity is given by dr by dt, so we have to differentiate this value. So this is nothing but d by dt of a cos omega t I cap plus d by dt of a sin omega t j cap. On further solving, we get, first we differentiate this cos function, we will get minus of sin omega t, and then we will differentiate this omega t, then we will get omega, and here it is a. So this will be minus a omega sin omega t I cap plus this is a omega cos omega t j cap. Since the direction of position vector is always away from the origin, so it is directed away from the origin. Away from the origin. Now, from here you have taken omega outside, so you are left with minus a sin omega t plus a cos omega t. Now observe this value. Here we have the term cos omega t I cap, and here we have the term sin omega t I cap. Here we have the term a sin omega t j cap, and here we have the term a cos omega t j cap, isn't it? So whatever arrangement you do, but it will never equal to this value. I mean, it never gives the value that is some constant multiplied by position vector is equal to velocity vector, isn't it? So neither it will direct it towards the origin, nor it will direct it away from the origin, because in both the cases it must satisfy the relation v is equal to k times position vector. If k is negative constant, then v is opposite to the direction of position vector, that is towards the origin, and k is positive constant, then what happens? Velocity is away from, that is velocity is having same direction as position vector, that is directed away from the origin. But what happens here, if I observe the expression of this velocity vector, it can never convert into this way. This is never possible. So the two options, directed towards the origin and directed away from the origin, is cancelled. The second thing again is parallel to the position vector. This is also gets cancelled, because so the one option remains is that is perpendicular to the position vector. So this option may be the right answer, but if the dot product is 0, then we can say that the two vectors are perpendicular to each other. So I am writing here v dot I. I am finding here v dot r vector. So v vector is given by minus a omega sin omega t I cap plus a omega cos omega t j cap dot a cos omega t I cap plus a sin omega t j cap. We have minus of a square omega sin omega t cos omega t plus square omega a square omega cos omega t sin omega t. So this will be 0. So we can say that since the dot product of position vector and velocity is 0, so velocity must be perpendicular to position vector.